Hi, I'm James McGuire, and today we're talking about virtual machines. Everything about VMs, certainly the virtual machine has been the mainstay of the data center for many years. To discuss that, I'm joined by Michael Roy, product manager at VMware. Hello to you, Michael.
Hi, James. Thanks for having me on.
And certainly, I know you know a lot about virtual machines. Why don't you give us a little bit of your background in terms of how you've worked with VMs over the years?
Yeah, sure. So I've been with VMware formally for 10 years. I started on the Fusion and Workstation support team. I actually created it. And I actually run the Fusion and Workstation business now. So I've kind of gone through the ranks a little bit. I took a
Okay.
stint in the middle where I ran the vCloud Air technical marketing. So I
Okay.
ran a lot of like developer oriented and security oriented stories and technical solutions around how we were using our vCloud Air service at the time. But before that, I was a system administrator at a small data center in Toronto. We used a variety of different hypervisors at the time. And I used, virtualization really as a learning platform as well as a production thing. At the time, it was like 2005. It wasn't as mainstream as it is today, but
Right.
it was a great learning platform. Being able to have different operating systems on the same computer really helped me learn a lot, get a lot more deeper with Linux at the time. Our data center was based off of Gen 2 Linux, so it's a little thicker than your normal, off-the-shelf Linux distribution. So you needed a machine that you could very quickly roll back or make changes to that weren't going to affect the hardware or weren't going to take like 4 hours to reflect that change. So
Right. So
virtualization really
yeah,
made that possible.
you were actually working in data centers before virtualization?
Yeah, it was about, well, I mean, virtualization had been around for a long time, but before like VMware kind of was the de facto standard, there was a lot of
Right.
interesting solutions that were trying to sort of attach that in the data center. But it was like, open up a box, it's command line, type the command to create a VM. It wasn't anywhere near as sophisticated as it is today.
Right. Right. So let's talk a little bit about virtual machines and containers. I think there was a sense when containers really burst upon the scene. I think it would have been like spring of 2014 or somewhere right in there. It was like Docker was all the buzz. To this day, I think some people are not completely sure. Virtual machines versus containers. What is the difference there?
Yeah, it's a great question. And it's something I think in the industry we sometimes take for granted, but it's really
Right.
simple. You can think of a container as an isolated Linux process. You can think of a virtual machine as an implementation of a physical computer. So they're very different. At the end of the day, they provide a level of isolation. Generally, you're going to run some app in it. Apps need an operating system to run, and you need to sort of have a way to isolate those processes in a distributed system, in a big system, right?
Mhm.
So virtual machines are a way to isolate each of those processes in a way that is actually bound by this thing called the hypervisor. And that
Right.
hypervisor talks to the CPU and can coordinate all the different calls between the host operating system and all the different guest operating systems. So virtual machine, the barrier there is the operating system is running, thinks it's inside of real hardware.
Right.
Whereas a container has no notion of the operating system or of the hardware around it. It only knows that I need a chunk of the Linux kernel. And the Linux kernel has a feature in it that allows the kernel and the threads to be broken up and separated. And those separate threads are isolated in a particular way that is a little different from a virtual machine. So it's like a bunch of processes on a single computer versus a whole bunch of individual computers.
The container is certainly a leaner, smaller item than the virtual machine, correct?
Yeah, because you don't need the overhead of the operating system, you can really just pare it down to only the components that you need. And that, makes it very, very distributable. And further to that, containers can be defined by like a very small text file.
Mhm.
Whereas a virtual machine, you need the virtual disk that has like all the bits directly on it in order for it to work, or you have
Right.
to install the operating system from some ISO image file. Whereas a container just pulls it down from the net, all the different dependencies, and you describe all of those dependencies in code. It's very remarkable technology, but it's not a panacea. Not every app is designed or written is appropriate to be inside of a container, but that list gets smaller and smaller every day as the technology improves. And that's just due to the nature of open source. It's moving very quickly.
Well, I mean, I think some people say that the virtual machines are, in competition with containers, but in fact, the two, live side by side.
Absolutely. And that's actually the best of both worlds, right? Because you have the security isolation and the management controls of a virtual machine. And then if you put that virtual machine as a Linux thing that can run containers, now you've got an extra special double barrier there, so to speak.
Mhm.
And we've taken that to the next level at VMware. We introduced at VMworld this thing called Project Pacific. It's not shipping yet, but it's a rewriting of our lower level hypervisor so that it runs containers and VMs basically at the same level. So there's this
Hmm.
like really tiny virtualization layer around the container, and then you
Mhm.
have your typical VM, which has the bigger stack. It's pretty incredible the stuff that we can do by baking it into that level, but it gives us the ability to like, take a small descriptive text file, give it to the host, and it'll automatically create this application that wasn't there before.
Uh-huh.
But it's a really remarkable technology.
Let's talk about virtual machines in terms of use cases. I mean, there's some more common use cases, but what are some, a couple of really common use cases, and maybe some use cases for VMs that aren't as thought about as much?
Yeah, sure. The thing about virtualization is it's kind of everywhere. So when you think about like where it is, like anytime you open up a web page, 99.9% of the time you're hitting a VM running in somebody's data center,
Right.
some cloud, if you will.
Hmm.
And really all the cloud is just the orchestration of all these different virtual machines and containers, right? And being able to sort of automatically deploy that stuff for client consumption. But so there's every web page you've ever been to as a virtual machine. Certainly on the desktop, with Fusion and Workstation, you have the ability to run different operating systems, whether you're doing development and testing, or you want to run a video game from an operating system that's no longer supported, those types of things. But there's some really odd and interesting ones. Like we have the ability to pass, old devices and serial ports. So you'd be surprised, like places that have like really old roller coasters, for example, that have a very special piece of hardware that controls the roller coaster software. And that thing is only debugging able using like MS-DOS or some older operating system. So
Wow.
you need to support the roller coaster or whatever it is. So you have to have a way to support that older operating system. And a virtual machine is a great way. So they'll put like a virtual machine on a laptop, go over, plug in via the serial port, and then start debugging and fixing it. Auto assembly plants, you'd
Wait,
be
just
surprised.
to be clear, are you saying there's somewhere there's a roller coaster that is actually being run by DOS software? I want to maybe I'm not totally understanding you.
No, that's exactly right. If you can imagine a roller coaster that was built in, the 80s or 90s,
Right.
we didn't have the same ecosystem of software that we do today. But that
Sure.
hardware, you're going to build that roller coaster or assembly line or whatever plant, and the software that's going to run it is just what's available at the time. But you have to
Sure.
support it, and it needs to be maintained. So it's not really worth it just to like update it to the latest greatest thing. It's sometimes better just to keep it alive, and then you have
Sure.
virtual machines that can support it and debug it, and if things go wrong, and keep adding to it without needing physical hardware. Like you probably couldn't even install DOS on a modern computer anymore, so you would need a
Right.
virtual machine to do it
I
anyway.
mean, tell me, would you get on a roll? Would you get on a roller coaster that's being run by DOS? Just a personal
Oh
question.
man, absolutely. I mean, like
Okay.
if you could read the program that sent the Apollo lunar lander up to the moon, I mean, like it's just assembly code, right? Like it doesn't matter how
Yeah.
old it is. It
Okay.
does what the computer does. It does exactly what the code says it's supposed to do.
Right. Right. What about some challenges for virtual machines? I know there's some IT administrators that pull their hair out dealing with virtual machines in some instances. What would you say are a couple of typical challenges and how you might get over them?
Yeah, sure. One challenge that always comes up is performance. How do I make my VM run faster?
Right.
And depending on where that VM is running, it's generally going to be a kind of give and take between what your host computer is and what you want the virtual machine to do. So if you take, for example, a laptop and you got a VM on it, you generally don't want to give more than like half of your system resources to the VM. Um, you can give more if you're really like only living inside of a virtual machine, but you want to leave enough resources on the host so that it does the things that the host needs to do. So the host
Mhm.
meaning like, if you have a Mac, that Mac needs to swap RAM, it needs to run programs aside from your virtual machine. So performance is always one, and sometimes it's easy to overcommit. So you apply too many resources to it, and then you have a problem which is called contention. And that happens in the data center a lot, where you have all these different VMs fighting for the same resources. And
Right.
there's some really interesting ways of sort of uh, guaranteeing some resources and preventing other things from consuming those resources, and then having extra resources available that are shared. So you can give everybody a certain baseline, and then they have this sort of room to share and play. So that requires some fine tuning, and it always is going to be dependent on the use case, right? Some systems
Fine tuning in
need
terms of how
more.
you allocate RAM, or what is the fine tuning about?
Well, RAM as well as other resources. So it depends on what the app is trying to do. Some apps,
Okay.
for example, if you've got a database, there's a good chance it's going to be disk heavy. So you need to have fast storage or redundant storage or what have you. Some things are going to be more computationally heavy. So you're going to want to apply more virtual CPU cores to that machine or whatever.
Mhm.
So it depends on the use case, and there are different characteristics for each use case. Like playing video games, for example, in Fusion you can configure the amount of video RAM that you're giving to the guest. So you might want to give it more if you're going to be playing a game, and less if you're just doing spreadsheets or something like that. So it's
Right.
usually just like a balance between the available resource that you've got based on the task that you're trying to accomplish.
What about if you look into your crystal ball, the future of virtual machines? I mean, certainly, VMs have been, a key part. I mean, they've had what in the tech world might pass as a long history already. Where are we going with virtual machines, and how can a company get ready for that now?
Yeah, well, it's 20 odd years we've been around, right? It's
Right.
it's not
Right.
yesterday's technology, but it's amazing how fresh we're still able to keep things. I know here there's a lot of very interesting things coming up around very narrow use cases. So I think what you're going to see in the future is very purposeful virtual machine architectures. So
Mhm.
things like AI and ML. As an
Right.
example, right? Those have very
Right.
special characteristics, like I was mentioning about performance. AI and ML workloads need a ton of disk I/O because you're feeding in an incredible amount of data. You need to
Right.
have generally some sort of CUDA or some other type of GPU-based computational engine that can do different kinds of math that your CPU can't do, and that gets a little different when we're trying to work things into a virtual machine. So I think you're
Hmm.
going to see things that gets a little more specialized, especially when you look at things like edge and IoT. This
Right.
whole 5G wave, the way that 5G works is you have to have like more cell towers, and those cell towers have to have infrastructure like right at the tower. And how do you do that? Well, virtual machines are a great way to do it, but virtual machines, as they were what we were saying before, can sometimes be pretty big. So we need to like streamline them and make it so that they're appropriate for that use case. So where
Mhm.
we're going is, I think that's where things are headed. Is very more prescriptive, very narrow use cases, and a lot more of.
That sounds great. Michael, thank you very much for sharing your expertise with us today.
No, thanks for having me on, James. Really appreciate it.